talk and dance a little bit to give Josh some time.
Okay, let's really have a dance.
I am not going to dance.
You suck at that.
No, I lied.
Wolfgang style.
No. Just no. Just
No matter how hard I tried, he would not get up there.
I would not. I would not.
Name for Jennifer, come on. Jen.
Sorry.
For my sake.
So the software development lifecycle, in terms of building software, pretty well known if you're managing software projects. The security aspects of it, more recent, and incredibly vital because I'm going to keep talking to you, sort of gesture to you that you're ready.
You just keep going.
Okay. Because things are going to happen, right? We're going to get attacked. Our software is going to get broke. Our first layer of defense is going to get breached. Our second layer of defense is going to get breached, and so on and so forth, until finally they either get our data or we stop them. And the only way to stop them is defense in depth, user training, software controls, hardware controls, what have you. And it's important to notice that even the best people make mistakes. And I'm not going to point anyone out. I won't do that. I don't know. Did you guys see this? All right. Let me explain what we're looking at. And again,
You keep going, man.
This is Doppler. Doppler is a open source tool that was demoed at BSides Detroit, and it captures all the pictures of what you guys are Googling. It'll also capture open text passwords or clear text passwords. So let's just stop for a minute and define security. Security is what? Security is the ability for the good guys to protect an organization, specifically an organization's ability to achieve its mission. So what is the mission of a CTF? The mission of a CTF, to capture the flag, is to provide interesting challenges, good challenges, to provide a fair challenge, right? We don't want people cheating or giving things away. To provide a level playing field and provide a really good time. BSides Chicago and BSides Detroit, to the best of our knowledge, for the first time ever, we did a two-city, two-conference capture the flag event. Started at Chicago, had 25 flags, went across online for a period of time, flipped over to MySec, had another 25 flags at BSides Detroit. And we just so happened to have, on Ben 10's site, all the answers to all the challenges. And so Derek accidentally exposed the clear text password on a giant wall where all the CTF hackers were watching, and made this face over here. So
let me just jump in here real quick and say, in DTOM's defense, he was on the hotel's network to begin with, and we were still trying to get the CTF network up. Well, he had logged in previously to my site, and the credentials were cached. When he switched over to the CTF network, it said, "Oh, I see you're on a new network. Here, let me resend your credentials for you." And then that's when it popped up. So it was out of sight, out of mind, not a proxy. I didn't have an SSL cert, so there were multiple points of failure. It wasn't just DTOM. So I've got to defend him just a bit there.
This is no fun. We want to beat him up.
Ben 10 does need to defend DTOM, and I am, of course, exaggerating a fact because I'm DTOM's client and having a little bit of fun. And I was hoping you would be here because it would be more enjoyable. But the bottom line is, even the best of us make mistakes, right? There's always going to be a security failure somewhere in the line. For example, storage guy might leave a projector unlocked. I don't know. Even the best of us make mistakes. And so that's why it's so vitally important that you have a secure development lifecycle and that you have multiple layers. So we're going to walk through the software we wrote to the framework, and we're going to show some strengths of it, some mistakes of it, and how the strengths compensated for those mistakes, and how even when we did have a security breach, it's what I would refer to as a zero impact breach, because it did not impact the mission of the organization of a CTF, meaning when the breach did occur, it did not degrade the performance. Thanks for joining. Can you mute your mic, Feltfish?
on top of a ceiling? How do you have wind?
He's in a car.
Yeah, I got you.
Can you mute it? Thank you. So zero impact breach, no impact due to the security controls that we put in place due to Ben 10's fast acting instant response and what have you. Are we ready to switch to you?
We can do it.
All right. So you got,
Poorly trained storage guy would leave a laptop on.
I'm not even going there. So you got slides up?
Oh yeah, let me get slide. Where are we? Yeah, we. There we are. Okay. Yeah, so we're gonna kind of go through this talk fairly loose. So please ask questions. We can roundtable this as much as we want to. So yeah, so when we're talking SDLCs, you know, everybody's got that that classic textbook. Well, this is how you run an SDLC program. This is how you design secure and lasting code. And so, I mean, some of the stuff that we've got up there is some of those basic ideas that you have with SDLC. You scope the project. You've got a management buy-in, whether for just business requirements, security requirements, so on and so forth. You're kind of going to do some risk assessment stuff. You're going to do some threat management stuff, or threat modeling stuff. And you're going to establish your security and privacy requirements. So hopefully those things are all built into that estimation point of the project. You've got that stuff built into the actual expectations that are being given to the people who are actually building the software, so on and so forth. So that's kind of, we'll talk about the textbook stuff, and then we'll kind of see how this actually goes into in practice when you're designing a site that you know is absolutely going to be, you know, thrown things at constantly because, well, you're allowing hackers to play on your framework. And that's what they like to do.
And I think we got a lot of these, right? I mean, I don't know who the management of the conference or the CTF would be, but I'm sure that all of us agree that we should probably make this secure.
Right. Well, some of it is because if we didn't, we'd have the laughter of our own peers.
And then someone would throw up a slide and we give it back.
Right. I mean, so you know, and you know, we'll talk about one incident that kind of did happen. But yeah, I mean, if we were just imagining the amount of you know, ridicule things like Symantec gets when they throw up an advertising site that's riddled with security flaws, or you know, McAfee gets hacked, or X security vendor has X massive hole.
What's the web application firewall vendor that?
Oh yeah, yeah. When Barracuda fails to leave their own WAF and they have a MySQL or SQL injection against their website. Yeah, yeah. We all know about those, and we don't want to be that person.
So we had management buy-in in this scenario, which is something that internally I know is often a fight when I'm working my own software project, but definitely something we didn't have in this scenario. We had a fairly good risk assessment. Yeah, this is risky. People are going to try and break us.
Yep.
Cheat. Security and privacy requirements, we had those.
Yep.
So good.
Yep. I'm waiting for you to click the next slide.
No, you've got the clicker.
I got it now. Okay, so really, where did the CTF framework come from? All right, so what was the original reason for this and whatnot? So originally, when this was written, it wasn't. Oh, you.
Your mouse is driving. That's good.
Okay, this pet peeve. So originally, this thing didn't actually turn out to be, or it wasn't really even intended to be used as this kind of live, let's actually run a CTF off this thing. So DTOM hits me up one day. You know, we'd been playing a lot of CTFs, and we'd been having a lot of new people coming in, and he's like, "Josh, we need like a WordPress site that I can go and put challenges up on for somebody to actually use. You know, so we can train people on some of these CTF stuff, and we can get better, and people can write their own stuff, and we can trade them back and forth, and yeah, that'd be cool." I'm like, "No, dude, WordPress sucks for that. I can write just something better, all right? And I should know far, far better than I already do that I should never volunteer for stuff." But I did, and I was like, you know what? We'll make you a framework, and you know, to justify it to myself, I'm like, there's all these new secure coding paradigms that I want to play with. Yeah, I'll write those things in there. It's a CTF framework. You know, it's a site for CTF stuff. It should be fine. should be granted the rights to add their own CTF challenges. So we could have people designing CTF challenges for everybody else to play with. If you had a cool idea for one, you could put it up there and see how the rest of MySec did against your CTF challenge, things like that. And so like all good projects, there was scope creep. So it went from being a training site for all of us to running 2 fairly large, full-scale live CTF events to now even worse, a downloadable open source framework that will eventually be released so that other people can do the same kind of thing.
Yeah, because I was out at Boston, and I was talking with the gentleman who heads up the internal security function for Harvard. I'm like, you know what we got? We got this framework. You want it? Josh can do anything. And I emailed you. You're like, hey, guess what? And you're like, you did what?
You did what?
I thought you were going to be happy. You're like,
oh,
tell them to do it on WordPress.
I'm really very shocked at the amount of interest. Well, not really shocked. It's really nice to see the amount of interest that is coming out in the framework. It's the idea of getting the code reforked and cleaned up and
a lot of work,
and all that stuff. Because again, so while I built security into the framework to begin with, I didn't build it with the idea that this was going to become a downloadable package that everybody else can then go in and install. And while I'm fairly, much more some people are, I'm religious about commenting my own code, even if I'm the only person who's ever going to see the thing. But yeah, there was certainly some stuff and some of the big challenges we had in translating it from where it was originally, because again, I also didn't envision this to be moved around. I think we've got, I don't know, Ben, probably 5 or 6 different throughout the life cycle of this installs of this framework out there, everywhere from a couple different development servers I have to the one that we were using originally for MishSec, to Ben's one that we'll take a look at later, and then moving it to an AWS instance, actually 2 separate AWS instances throughout this.
And transitioning it from site to site throughout the CTF.
Yeah.
Because wouldn't it be cool if we started at Chicago's website and switched to Detroit's website? That's easy. It seems easy on the call.
Right, exactly. It always seems to be. You guys are like the sales and business people. Can't you just do that? That sounds like a really easy thing.
To me, that's kind of funny because scope creep is not something to teach you in school, but it's something that my team deals with every single day, and the users drive me nuts. I'm like, what, you said it was this. And then I'm suddenly the user, and I'm doing the same damn thing.
That's right.
So.
And so, I mean, some of this, especially when we're talking about going back to the overall concept of the SDLC, scope creep, aka changes in the business requirements, really can mess with the security of the site. There's actually been several assessments that I've been run recently where when we've been going over the web results, the guys actually kind of laugh and go, yeah, that was the last function that we just added recently. And that right there is an indication that, you know, the scope creep, you've exceeded the bounds that you originally designed this application for. So when you sat down and set up your assumptions for security or functionality or whatever it is that we're talking about, there was a given set of assumptions. At some point or another, those assumptions get stretched to a certain point where they no longer apply universally across what you're trying to code. And so you start coming up having to go, okay, well, yeah, we didn't envision that going to happen, so let's try and code it this way, and eventually that's where you start getting those little chinks in the armor. And so the more you can kind of design and kind of anticipate some of those scope creep ideas and have a framework and a paradigm that can kind of stretch farther than the average bear in a sense, you're going to have a much more robust application. Okay. So again, here we go, talking about design requirements. And I'll talk really about the third one right now, threat modeling. Okay. Threat modeling is where you kind of get that ability to stretch and to move beyond your initial set of design requirements. At this point, when I was sitting down and writing this framework, one of the first things what I was doing when I was designing the actual security model that was going to go into it was to kind of brainstorm all the things that I could think of that could go wrong with this. All right. So what are our requirements, and how are we actually going to? How would we see these things going wrong? So I actually have that as the next slide here. Yeah. Oh, cool. So in the original form, we have a couple big categories of threats. Okay. So everybody loves SQL injection. So attacks against the database engine. So attacks against the input into the actual data store were a primary threat. All right, you can just think of that. Okay, what do we do with web applications? We try and do SQL injection. Cool. Let's make sure that this thing can't be hit by SQL injection. So you have something for CTF specific things, integrity of the scoring system, making sure that people can't hijack the way that the scoring system works, can't hijack the way in which answers are submitted, in which answers can be submitted multiple times, or incorrect answers taken as correct answers, anything like that. And then since we originally were talking about using this as a multi-user and multi-user generated content system, we needed a way to make sure that somebody couldn't just throw in script, my malicious JavaScript, end script into a CTF challenge and have that execute on everybody's browsers, because, yeah, well, that would be fun, and it's kind of not awesome. I mean, really, it's fun for the guy who figures out, yeah, I could do this, and I'll hit everybody and make everybody, pop up an iframe with hamster dancing or something. Or something, right, exactly. That's all fun for about 5 minutes. I think it's really obnoxious, and then you have to go clean the stuff.
I have to admit, in early stages, having seen your cross-site scripting, I always made sure that you weren't like keyjacking my box. Every time, that's okay.
Yeah. Hey, well, go look at this challenge for me, please. Let's sideload all of the rest of your pages into this iframe.
Wolf doesn't trust anybody for some strange reason.
I don't know. I don't know. So. That's right. So, and then when it came to being, the actual CTF form itself, the final form that we're talking about here, availability of the framework was big. So, I mean, if the last thing we want to do is try and run a CTF event and have the framework be down for half of the event. Are you CTF? So,
too soon.
So yeah, so they were much better. And then traffic interception, of course. I mean, going back to the very first slide, the last thing we want to do is have somebody sniffing unencrypted wireless traffic, or dropping everybody down to SSLv2 or something else like that, just to be able to pull flags right off the wire, as opposed to actually having to work for them. So I mean, those were some of the general threats. I mean, if you can think of, okay, how would somebody attack a generic CTF framework? And all of those then became, security requirements that were then built into the application itself. A lot of it because of the dual nature of what was going on with it, the combination of the fact that, it was intended, even if it was going to be intended to be used just by us originally, it was intended to be used by a bunch of people who like messing around with software. So security couldn't just be an afterthought, or, oh, nobody really thought about security because it's just a B2B website. Nobody would mess with a B2B website. So from the very beginning, we had to make sure that security was in that project. And that kind of, again, let us, as soon as the earlier you get security and secure frameworks put into your into building an application, the far easier it is to kind of work with changes, and to also make sure that anything that you need to do within that application isn't going to break something else. I mean, if I've got a secure framework that I'm building this application from the ground up, I don't have to worry about 6 months down the line when we're weeks to launch, and the security team just assessed the application and said your entire database routine has to be rewritten because it sucks and it's filled with holes. You can then kind of use that, because we always know that if there's a choice between a QA and a user experience issue and a security issue, in most organizations that QA and user experience issue is going to get fixed prior to launch, and the security issue isn't. If you don't have to worry about that because you designed a very robust security system from the beginning, and maybe you've got, okay, yeah, you missed one application here and one application here, and the change in the code is changing the function name, or, oh, we didn't put this back through the output sanitizer, so here, let me write one line of code. That's a heck of a lot easier of a fix than going, well, our entire database library sucks, so we've got to rewrite it and retest every single page in the application. Right. And then again, because of the fact that I was using this originally as a playground for new security features, that kind of made it easy to write them in at the beginning. Okay. Just a little bit about the actual security features that go in there. So essentially, pretty much all the CTF functions were all in just one big single PHP class. So pretty much everything that was really any kind of, even just minute little functions, were actually given a function and made sure that they went through the same rigor that some of the really, really large functions and really sensitive functions were being there. All the database functions were handled by a set of abstraction functions that were all based around parameterizer prepared statements. So anybody that's heard me harp on SQL injection, you know that I always say that the only thing that's going to actually really, really stop SQL injection 100% of the time is parameterized statements. So essentially that's where we're compiling essentially a set in stone version of our query logic, and that at execution time, we're throwing data into that and executing that SQL query, as opposed to concatenization, where we're essentially taking a textual string and throwing in line all of our parameters that we're going to use. Let's see. We'll see. I don't want to go too much because I don't know how. There we go. All right. So we'll take one example here. Okay. So this is the do login function. That's great. All right. I don't know if you guys can see this. Let me see if I can. Is there text? I never have to blow text up in this because it's always. You know what? I'll do this. I know this is already big. Hey, there we go. Can everybody kind of read that? Okay, so essentially we've got a just real basic select statement here. Okay, it's not basic. I mean, there's joins and all kinds of other fun stuff. But essentially, we've got our one clause here where username equals question mark. Right? This whole thing, when the prepared statement is actually prepared, and that's why it's called prepared statement. Essentially, this whole logic is set in stone. So regardless of what we put in here, so we can either be it like J Smith if your name is J Smith, or you can be J Smith single quote union select all users from MySQL.users, whatever. It really doesn't matter. All of that stuff becomes just data, and it gets sucked into this little placeholder. And it can no longer affect the actual logic because the logic's already been prepared and set in stone. Okay, so there's this do query routine here. Essentially just takes in the SQL, the type of data that's being put in there, and the actual data itself. So we're trying it string data, and we're throwing in the username, so on and so forth. It makes for a nice, secure database connection. Okay. To prevent CSRF, cross-site request forgery, Originally some, and hopefully at the very end, it's kind of funny because there's a big note in my still to-do list on the framework, which was tokenize more forms, and we had one guy kind of call us on the fact that one form wasn't tokenized. And I was like, oh, okay, kind of fun. That's distinctly in my notes to tokenize more forms. And again, this comes into something where the tokenization of the forms wasn't actually part of the original design spec that I had in place. So it was something that I added on later. Okay, so of course, like anything you add on later, it's going to come on incompletely. So there are still forms out there on the CTF site that are not tokenized. So what I mean by tokenized, so essentially, who's familiar with cross-site request forgery? The idea? All right.
Not yet.
So essentially, cross-site request forgery is it takes advantage of an already established session with a browser to force a user to generate a request of the attacker's choosing. Okay, so let's say we've got a get-based URL, which means all the parameters are in the actual URL itself. Let's say it's wire $10,000 to my evil account, and I drop that into, let's say, Bank of America's customer complaint forum as my image tag. Image source equals transfer money to my bank account. Any person that goes to that forum that has an active session with Bank of America and that Bank of America forum has this flaw in it would then transfer money because they're going to make that request. The server is going to say, thank you very much, Joe. I see from your session ID that you're Joe. I'm going to go prepare your request and send it out. Thanks a lot. The image isn't going to display because it's not a real image. Fine. The way to prevent that from happening, besides having bad get-based URLs, is to, at every generation of the form for that user, is actually send down a specific token that is then associated with their session. So when that user generates that form, bam, I'm going to send down this token. And if that token doesn't come in with that request, and that token then doesn't match the one I have on file for that user session, I nullify that request. Okay, so it's essentially a way to prevent people from incidentally sending in requests to a form and having actions being done on their behalf. We set up those forms as tokenized, and another big thing that I'm really kind of anal about is sanity checking on input and output. Okay, so everything that's coming into the frame input-wise is being thrown through some kind of a sanity check. For the most part, there are some large text-based form fields, especially in the section where you're talking about adding your own content, that are not checked because it's just such a large, there's such a wide variance that this could be in, or it's just like, okay, it's not a big deal. Yes, sir.
Is it safe to assume that the fields that you didn't check, it would be very difficult to do damage with anyways?
Correct. So, again, this comes back into defense in depth, in the fact that I don't care what the input is that's coming into my SQL statements because they're all injection-safe SQL queries. I'm doing context-based encoding on the output of these. So even if it comes in tainted, it's not coming out tainted. Okay, and so I'll talk about that in a second. But for the most part, I'm doing some checks based on this, and some of this is actually feeding into some of the other defensive functionalities that's in the framework itself, in the fact that when I'm receiving, let's say I'm expecting a single character integer for this return, and I come back in the request is sent in with a 28 character string, well, I know that didn't come from my application because the application doesn't send in that. It sends it in as a single character integer. That must be somebody messing with this. I'm going to log that. And if it's something that's really important, I'm actually going to kick them out of the application completely.
So input validation, output validation,
correct.
Logging, and active defense.
Correct. All are in the framework. Okay. And so when we're talking about output sanitization, we're doing context-based output checkings. So depending upon where we're throwing this information into, whether it's into a value form for a field, whether it's into the HTML body, whether it's going to be into JavaScript, we're going to deal with output sanitization a little bit differently with each one of those. So, so that's why we can take tainted data as long as we're making sure that we're throwing that back out each time. And so anytime we're printing stuff back to the user based upon any input that was in the database, it gets through a sanitization routine. And really, at that point, it's one function within the class.
Are you doing a little overkill then, because you're doing both your input and your output?
No.
I mean,
Correct, because some of it is I don't know exactly where that data may be coming from. Some of it may be I'm not going to do one routine going, okay, well, we knew we kind of checked it at the beginning, okay, but we're not going to bother checking on the output. Also, maybe I missed something on the input. Maybe I failed to write a sanity checker on the input, and we missed it. So at this point, we're now going to have it on the output as well.
more of your layers of your protection there.
Exactly, exactly. So if we missed something, or if there was a context that we were not expecting, whatever it is, we're going to try and also get it on the output as well. Okay. The access control and the access model is all role-based. So each user is, I can kind of bring this up if I can see it. Where's my, excuse me if this is way slow because it's through a remote desktop session to my house, because for some reason Wolf's network is blocking the JavaScript files from all of our CTF frameworks.
Given that Wi-Fi got you on?
Yep, yep. Yeah, I don't know what's going on, but yes, it is.
So layers there, Wolf.
That's right.
Defense and depth.
That's right.
How would that implement it right?
Yeah, I can't even undo it.
There.
So
It'd be too dangerous if I knew the code.
that's right. So
They don't have to kill you.
What did I do?
each user could then be added to various different actual roles that were within the framework. And some of these things are leftovers from the original use of the piece. So, you know, the ability to even access challenges. If you don't have that, you don't even get to see the challenges page. You don't get to actually run any of the functions that deal with presenting challenges back to you. The console is the actual administrative console piece. You've got the ability to even add a challenge. So if you don't have that flag, and either you tried to go on at the presentation layer to the add challenge page, like this thing up here, or if you tried to just submit data to the handler that takes in challenge data, you're going to be denied because it's going to do a check each time it's trying to run that function to say, hey, do an access check to see if user X has the role add challenge. If not, kick them out. Is admin is kind of a role, and so on and so forth. So each one of these can be added individually. You can kind of see there's a manage challenges and then there's a modify challenge, and manage users and manage profile. These things are both the challenges and users are global roles, where the manage profile and modify challenge roles are individual to the actual database object that's in there. So if you were to come in and add a challenge, you'd be listed as the owner of that challenge. If you tried to modify that challenge, it would succeed because you're listed as that database owner, and it's actually going to do a check to make sure that your user account is associated with that specific challenge. If you tried to modify Wolf's challenge, you're going to, no, that's not your challenge. Same thing with the users. So that's how we kind of got around that classic idea of the increment by one to access your neighbor's credit card account in the bank software, something like that.
This was fun testing out. Hey, Wolf, can you go add a challenge? I can't add a challenge. Good, my security's working. Can you not try? That's not working. Good.
Right.
I knocked you out.
Right, and especially early on in the framework where a lot of the administrative UI was not there and most of it was being done by hand massaging the database.
Right.
Wolf's like, hey, I need to update this challenge. We're like, okay, well, let me change the UID in the database so that it's yours, so you can actually go and modify the challenge. Okay. So access checks at both presentation, function, and data layers. That's kind of what I was talking about there. Presentation means can you actually see this page, or if you actually go to this URL, does it actually display for you? Function means can you actually present this data to this function? Data, can you see one record versus another in the database? All those things are all checked using database checks. They're not hard-coded in the page. So if you wanted to add a new page or a new section to the framework, all you had to say is, call it, hey, authorization check this role for this object. And then we have an internal event log that tracked all the sensitive actions and boundary checks. So we'll kind of take a look at that. That's kind of cool.
And I want to say something was bringing that up. I said to you a minute ago, logs didn't happen. I say that a lot. Because I really believe that. The very last line of defense always is instant response. The only way to do effective instant response is if you have logging. And when we get to the incident we did have, it was the logs and Josh's foresight that saved us.
Right. So we all know about, general system logs and things like that, and general Apache logs. So the Apache logs are good for telling us, well, what resources got requested, what was the result of that request, kind of who made that request, and a couple little bits of information about it. In a lot of senses, they're blind to what actually is going on in the application. If you're sending data back and forth using posts, those post data are not being recorded in those access logs, which is one reason why you're always told to use posts for things like putting in credit card information, so on and so forth. So that's not being tracked in the actual access log. So when I was adding this, I'm like, you know what, we're really going to need to know what's going on within the actual application itself for the defensive thing. So there's a lot of things where if a boundary check or an input check has failed, it actually will show up in here. And there's not, all these are operational things. So I can actually. Oh, that's probably a challenge that was updated. Let's see. So let's do this. Let's see if we can do this. All right, so we've got challenge ID equals 9. Oh, it kicked me out. Cool. So it gave me a 403. Huh? Yeah, go away. Let's see if I'm actually still logged in with this version. Okay. So that one actually didn't fully kick me out. There we go. So if you can see this line down here at the way bottom, actually, page missing get element required or value not matching type probable attack. Okay, so this allows an administrator to actually go in here and see real time whether or not people are throwing attacks at the application, what kind of, where exactly it was. So we saw it was in view challenge. We kind of saw exactly, in a sense, what the issue was. There's a full logging piece here that whoever wants to write a page within this can actually say, hey, log this message. Boom. You can see what page it was. We even go all the way down to seeing what session ID it was, so we can attach that. We know this was me because that's the applicant. Oh, right here.
Oh, okay.
The one that says ztango. There we go. And there's the IP address I'm coming from, date and time, so on and so forth. So we've got attribution, we've got a location, and we've got information about what's actually going on. One of the last things that I was actually doing is you can kind of see this column here, the ones and zeros. This was actually supposed to be a severity rating that you could assign to each individual piece. So if you wanted to say, hey, this operation is a possible attack, maybe something just messed up, I don't want to send off the bells and alarms, or, hey, you know what, this should never, ever, ever happen. If this does happen, raise the hue and cry. There was then going to be things like SMS messages, emails, that kind of thing going off, so that
shots back through the keyboard.
Exactly. Yeah.
Yeah, you'd even talked about dropping Metasploit payloads at one point.
Yeah, I did. Just kicking into a beef console or something like that. It's fun. So yeah, so that's kind of a little bit on the active defense standpoint. All right. What were we saying here, Wolf?
So when you actually go to implement it, one second. When you actually go to implement, it's very important not to be sending a text message or a tweet at the exact same time when you're talking to Slack. Pro tip. So when you implement, obviously you want to write your code. You don't want to use unsafe functions. You want to analyze your code doing static analysis, and then get it over to the users to actually do some testing on it. And as Chester already mentioned, we had multiple different implementation phases in this. I think we have another slide with some of the. So when we first put this together, the idea of a proving ground was to practice different CTFs. And then a lot of people were saying, hey, we want to be on the CTF team, so we organized a workshop. And we did 2 workshops, one of which was the MySec workshop, which we learned a very important thing about not making changes during a workshop.
Yes.
Did you want to talk a little bit about that?
Yeah. Yeah, if you're in the middle of actually using an application, right then and there is not the time to try and manually code either new features or everything else like that. So yeah, you're in the middle of the MySec workshop, and
simple.
Yeah, and there was one thing because
it's like working on the airplane while it's in flight.
Yeah, it's about that.
What's the problem? But look, we're all smart people.
Right, we should be able to do this. Yeah, it doesn't matter that the only network that I can get an SSH outbound connection to upload the new code is from the little short thing that's hanging out over there, so I have to hang over somebody's head to plug this thing in here and code this stuff this way.
You got the Slim Pickens head on, too. Like
exactly. Whee! So yeah, that's not the time to say, let's add new features to this. I believe it was, I think the one that I was trying to do when I actually broke it was the fact that if somebody copied and pasted an answer,
turn the white space.
It was to turn the web
How
space.
hard is that?
And that was a great idea. I'm like, because from a UI standpoint, from a user experience standpoint, if people are copying things in from other tools, it may or may not have visible white space that they're seeing. And of course, ABC123 space does not match the database record of ABC123. Therefore, you're wrong.
And I want to revisit DTOM for just a minute, because I kind of threw up the slide and I beat them up a little bit. But think about this for a moment, all right? I manage a dev team. We do changes all the time. We're enterprise grade, always up. As a manager, I should have known better. And you do code all the time. You do code review. Together, one of us should have went, no, we're not doing changes in production. We went, yeah, that's a good idea. Let's do it.
We're not deving anything. We're going to upload directly from the IDE onto the server. That can't go wrong.
Even the best make mistakes. So that was a good learning experience.
Yeah.
And then you did another workshop with EMU. I wasn't there.
That was Derek. Derek did that.
Derek did that all by himself.
Yeah. Oh, we also discovered that the first time that you needed to have a different way to register users, because for some reason the hosting provider we had the original version on, email was running 40 some odd minutes late. And so the original paradigm was the user registers an account, it sends them an email, they have to click on a validation link before the administrators even see the fact that somebody's registered, because we just didn't want spam bots to sit out there and register the thing all day long and have accounts filling up. We didn't want to have just random people filling things in. So we were like, well, we're going to have a multi-stage registration process. Well, that breaks down when your email server doesn't send email for 40 minutes to an hour and a half.
Right.
So yeah,
during a 3-hour workshop.
Correct. Correct. So yeah, so that was more manual database manipulation. I think we finally eventually just got rid of that function.
I like that option.
Yeah. So yeah, so we had the two workshops. It went pretty well because for the most part, besides I think in the EMU one, the only problem was one guy didn't get the idea that he had to click on the email to actually finish his registration.
Okay.
And so I kept wondering, because I was watching the event console while Derek was out there just in case he needed help with it. And kept seeing this one guy reset his password all the time. And eventually I IRC'd Derek and I said, tell so-and-so to just stop resetting his password.
It's not.
It's just not going to work. But it came off fairly flawlessly in the fact that I didn't have to actually be involved too much with
right.
learning that. So
And in a moment, I'm going to turn over to Ben 10, who's on the line, Ben 10 from Chicago. So the big scope jump was, yeah, we want to do challenges. Okay, let's do WordPress. Well, maybe you can do everything. And then we went, okay, we're doing challenges and improving on. This is great. Let's do workshops. We'll call it UAT. And then we thought, you know, those workshops went pretty well. How hard can it be to do a CTF?
Not a CTF, two CTFs.
Two CTFs over several weeks, which no one has ever tried to do before. We've done workshops. How hard can it be? So we recognized that a lot of changes need to be made in the code, and at that time, Josh's workload had really ramped up, so he wasn't as available. And Ben 10 had some programming experience, and Ben 10 jumped in to make some changes with very little interaction. I mean, the handoff was pretty much, here's all I got.
It was what, Ben? It was probably a 40-minute phone call at that.
Yeah, I think you and I called, and just to let everyone else know, I wasn't in the organization team for the CTF until about 2 months prior to Chicago. And at that point, they were like, oh, would you mind, project managing this for us? I said, sure, I can PM this, no problem. And then that's when, Josh is like, work is not there. The framework is not ready for what you guys want to use it for. We've got about, 35 to 40 man hours worth of work still left to go to get this thing up and running. And I think we had 2 weeks left.
Yeah, something like that.
And so I said, okay, well, I've written an application in PHP, and we use it for, 20 of our clients. And I'm like, well, I'll give it a look and see. I mean, I have no idea how much time it'll take, because when you go from your code to somebody else's code, there's always just a little bit of the nuances that go in there. So I said, yeah, sure, no problem. And you gave me access to the GitHub. I pulled it down, and I don't think I did anything for the next 20 hours straight. Do you want me to go into? Is that a good segue now?
Yeah, I think that's a good segue. I don't know what we've got going on, but yeah, just talk. Don't worry about the slides.
Okay.
Unless you got a specific slide you want to talk about.
Yeah. So what we had to do is there was a lot of the functionality that was had for the MySec team, and it was not ready for a dual conference. There wasn't specific events. They wanted to keep track of the score for Chicago, then they wanted to keep track of the score for Detroit, and then also have an overall score with the two scores combined. And that was nowhere in there. So I actually I think I did one push, and I typically don't do this. I do it in smaller pushes, but I did one push that made 2,732 changes to his code, to his GitHub repo. So it was just a lot of work that we had to crank through to get this thing ready to go. The nice thing about it, though, when he set it up, it was very structured and formatted. He didn't hard code anything. Everything was a function. Everything was a call. Everything was put in a specific place. So when I had to go in and make those changes or add features, I didn't have to rewrite entire things or copy and paste code. I simply called the function because it was there and ready to go for me. And I think that's pretty important when you've got a development and then you've got turnover, or you've got I've got to move this project from you to this person now over here, and oftentimes you're looking at somebody else's code, and again, it's unique, and that's where you get a lot of your errors or your mistakes, and you get that copy and paste code. Well, why aren't you using the secure function? Well, I wrote my own because it's really cool and slick, and I can do it in 3 lines. Well, yeah, those 3 lines don't have my 10 lines worth of security over here. And that was the great thing about working with Josh's framework, is I really didn't have to do any of that. I just came in and massaged it and made it, work for what we needed it to do. But again, he started from the beginning to making it secure, so that way when I came into the project, I didn't have to reinvent the wheel.
Excellent.
And that's all I have to say about that.
You want to flip to the next slide?
Good question.
Well, question, comment, because I'm new enough that I would ask this. Why would anybody, other than laziness or ignorance, write code that wasn't secure?
I blame the manager.
Well, it's not so much lazy or ignorance. Sometimes it's executives and upper management saying, we need this change, we need it now. It's going to cost us X amount of dollars if we don't get this to the client yesterday, and we're losing $6,000 an hour while we're sitting here talking about it. And
also,
go ahead.
I could speak for the federal side, is that many security teams don't know how to define what security is in terms that the business stakeholders can understand. So they're at a loss in saying, look, just do it. Because they don't understand, well, what secure code looks like and what it will do for the business.
And I feel like I should interject here. Another thing that takes into account here is that to write secure code is much more complex.
Oh, I get that.
So the amount of effort and time it's going to take to get the end product is substantially different.
Well, and that's exactly, and that's and on that point, because of how much time it takes, you have, it goes back to what Josh was and Wolf were talking about at the beginning of this, is all about that scope. You know, we scoped this out to the client at, 10 weeks, but we really didn't scope in the security aspect of it. Well, had we done that, we would have realized it would have been 15 weeks. Well, now we're short 5 weeks. Guess what? We have to make it or we lose the client.
You got to remember, from the client's perspective, they're not getting anything out of this, right? That extra 5 weeks is from the security standpoint, and as a business owner, why do I care? I want my product up and running. This isn't data that I care if somebody hacks and gets this, right? They're not thinking like that. They're not thinking the same mindset we do.
Excuse me, that's got to be a big problem.
I asked a good question. Keep going.
It sounds like a problem that's going to change as things become more and more digital.
How do you define that, the person who doesn't understand it? That's got to be one of the hurtful terms problem.
Yes. To be successful, you need a developer who understands how to code and do it securely. You need a manager who understands why they need the time to code it and develop securely, and has the backbone to say, we need to do this right. You need an end user who understands and is willing to make that leap of faith with you to say, okay, you can have the extra time, even though, to me, I don't see any difference.
And then you also need, finally, the person who can translate between technical risk and business risk.
Yes.
So if and it goes back to was it your comment? I think it was, essentially, if you've got developers and security people going, well, it can't fall to SQL injection attacks. Well, business, oh, what the hell is that? I don't know what that is. What are you talking about?
Put it in dollar amounts.
Right. Well, yeah, you can put it in dollar amounts, but you can say, hey, the data has to be secure at rest, and it has to be secure in such a sense that only authorized persons can get at this specific data. There needs to be controls around this. We can't allow some of this data to be escaped out and things like that. So, and then it's coming back to being able to take, okay, this was our business reason. Okay, so we need to make sure that no other clients can see other clients' data. Well, how does that translate into a technical reason? How are we going to actually translate that requirement into a technical requirement and security controls that exist around that? And that starts getting into the whole practice of threat modeling, which is something that people rarely do, and is really the piece that really takes all of this and puts it all together, is being able to say, these are our business requirements for the application. These are the business risks. We don't even want to call them security concerns. We want to call them business risks. These are the business risks that could exist in a application that's doing such and such. So if we've got a banking application that's transferring money around, it's pretty easy for even non-security people to think, well, what can go wrong with that? Okay, right. But even so, yeah, somebody else can get in there and see other people's transactions. They can make transactions on behalf of somebody that they didn't intend to. There could be, input errors that then, make for very, very large financial transactions. So those are kind of ideas from a business risk standpoint. And there needs to be some way, either developed themselves or someone that can go in and translate that and say, well, exactly what does that look like from a technical standpoint?
From a business manager's standpoint, I still don't care if it's secure.
Well,
Exactly.
yeah,
environment, though,
from a
maybe not.
strictly business manager perspective,
Right.
if I've got Josh telling me it will be secure and it'll take me 15 weeks, and I'm not going to take anyone in this room because no one would do it here, but I've got vendor A over here going, ours is secure, it'll just be 10 weeks.
Sure.
To me, at the end of the day, I see a login prompt, and I see I can get my challenges. I don't know the difference.
So trying to put that into real dollar terms, there are a number of studies out there, and I don't have these things in my head about it costs X percentage more to come back and fix those errors later than it does to fix them from the beginning.
Right.
And that's where you can put it into risk terms that they would understand.
And that's if they don't get breached.
If there's a breach, then they're
If you don't get breached, that's the bad news, because it's not going to be found for a long while. And somebody brings it to you, you still have to fix it. They're calling you up to the carpet and saying, you need to fix this because somebody might breach it. If it does get breached, your reputation is probably not going to go to hell. We've seen numerous breaches, and these companies still don't lose business.
Right.
3 to 7 days.
Well, and that's a good point, because talking about this, talking about the threat modeling that goes into it. I actually have an unnamed person client that I just will not mention. It's not a client of our business; it's a client of mine, and I presented them a lot of the stuff that was going on, and they came back and they said it's okay. Our incident response is that we're putting $5,000 of our revenue into a separate account, and we'll just deal with the breach notification and the legals if it happens. And that was their response.
Yeah, but it is
$5,000.
Right.
It is probably a small company.
But doesn't necessarily. I mean, if I can put $100,000 in layer piece of software, why am I going to spend $1 million developing? It's going to cost me
And further,
right.
and we're going to, and this dovetails into our next slide, getting back to demonstrating it, getting back to making sure it's secure, getting back to dealing with the issue of you say it's secure and this guy says it's secure, but you're actually doing it, he's not. It's vitally important you have that extra function that actually checks the security and holds the vendor accountable. And when I do SDLC, I make sure that's 3 different parties: myself, the company who's writing the code, if it's not our company, and then a third party who's doing the SDLC and actually checking and holding those vendors accountable. In our process, do you want to click to the next slide? We did a couple different things to verify it. We did a dynamic analysis and some fuzzing, which was done by Juan Cortez, Benten? Or Juan Carlos?
Yes, it was. It was Juan Carlos. I know it's Juan Cortester is his email, so everyone thinks it's Juan Cortez, but it's Juan Carlos.
Juan Carlos. So Juan Carlos, who works with Tenable, did our first pass analysis of the code, and our second pass analysis of it was done by Mark Stanislav, who went in through the code with a fine-tooth comb and picked out some things for us to improve on. But it's vitally important, because you're not going to know from a business perspective until you have someone else check it, because the vendors all tell you they're secure. I mean, you sit in enough meetings to hear every single vendor has told me that their stuff's secure. It's the other guys who are bad.
But Wolf, my code is perfect.
Yeah, your code and Josh's code, I believe, is absolutely perfect. No one would ever breach it.
Vendor management's got another.
That's right.
Yeah, coming soon to their review.
Yeah, just watch what you leave on the table.
We already covered that.
Yep, you just did.
Tell the vendors about how we'll deal with the one company.
Yeah, all you have to do is pull the gun on the CEO, and all problems go away.
Until you leave something on the table.
So in terms of textbook release, if you're following a formal SDLC, you create your incident response plan, which we actually did have an incident response plan in this particular instance, and that incident response plan was titled Ben 10. And he's going to talk a little bit about what he did on incident response. You conduct a final security review, which I mentioned we had Mark Stanislav do that. Unfortunately, in textbook, you do it before you release. Actually, we did it in the middle, so after B-Side Chicago. Would have been nice to do it earlier. You conduct a formal user acceptance test. I don't really know that we did that other than saying, yeah, we're going.
Right.
I thought that was, hey, Wolf, try this.
That always gets me in trouble whenever anyone in this room says that.
Hey, Wolf, try this.
UAT, I think, was the Chicago defense.
Yeah, our user acceptance testing was live fire. What do we got for the next slide? Release and practice. We are eventually going to release this.
Yeah, eventually.
Eventually, off of GitHub. We do have a lot of people who are interested.
Right.
But
we need a lot of cleanup to begin.
So where are we going here from here? Textbook response. So, look ahead a couple slides. Keep going. Keep going. All right. Where is Ben 10 slides?
Well, that's why I said that they were all the way at the end.
Oh, I thought we moved them around.
No.
Yeah, I don't know.
Oh, yeah. Well, if you go,
we'll jump back.
Yeah.
if you go back, you can see where it says "talk about it" here. So.
Talk about it here.
Right.
So
There was
at the event, we had a very motivated attacker, and we had a very diligent Ben 10. And with that as the setup, Ben, you want to take it away?
Yeah, sure. So it was Chicago, and not only was I helping out and running the Capture the Flag, I was also doing the streaming, and I had just done speaking at ThoughtCon and set up teardown. I was exhausted. I got home Sunday, and during the event of the week of the Saturday event, we didn't have any issues. But to be fair to Chicago, because it was only a one-day event, we said we'll leave it open until 5 o'clock Central Time on Sunday. Well, that's fine. During the actual event, Juan and Derek, they're sitting up there watching everything, making sure no one's messing around with it, so forth and so on. And on Sunday rolls around, and because I had the opportunity to actually get to know the framework, at a very intimate level, I knew what its capabilities were, and I knew what some of the security features were lacking. And one of those was, while they had the logs there, it still required a manual process to actually monitor those logs. There was no automated email system or alerts or escalations, things that would indicate that, I didn't have to sit there and watch the screen. Well, because I knew that I had to be that incident response. I wasn't just going to trust that there wasn't going to be a chuckle nut that was going to sit there and mess around with the framework. Well, lo and behold, as I'm sitting there watching it, we get a chuckle nut. This is my safer work word for the way I'm describing this person, so feel free to use it. It's MIT license. So I'm sitting there and I'm watching all these things go in, and as Josh had shown you earlier, where he has the alerts for probable attack, whatever, the entire log is completely full of these things. Not to mention the fact that someone who had registered the C75, Nick Percoco from TrustWave, yeah, they registered him as a person, and he had 6,542 points. And I said, oh, man. So I'm sitting there, I'm going in and trying to figure out what's going on. And so there were several things that he attempted. The first was the CSRF, and that was actually successful. He tried SQLI, but again, as Josh pointed out, he had everything parameterized, and he did the sanity checks. So all the SQLI or form trying to get something out of it, but it shouldn't have failed. The one thing he was able to do was resubmit the same answer over and over and over and over again, because in that form submission, it didn't do a check to the database to see if they had already answered the question. So he set up a script, and it just ran and ran and ran. And so I'm sitting there trying to stop this from happening because the competition's still going on. Well, I couldn't very well shut the entire thing down, so what I did is anything that he submitted, I just returned false. You answered it incorrectly. And that bought me some time so I could figure out how he was exploiting it. So I went through, fixed it. I'm sitting there banging on the keyboard. My 5-year-old comes over. He's like, Daddy, what you doing? I'm like, fighting bad guys. He's like, you are that? You playing a game? So he thought I was playing a video game, and I wasn't. And so I tried one thing, it didn't work. I went back, I tried another thing, didn't work, came back. And so I'm sitting here trying to figure this thing out. Finally I get it, and the log goes silent. And I am, you know, if you've seen my talk before, one of the things I'll tell you is that, you know, most security people have a healthy level of paranoia. I have an unhealthy level of paranoia. I'm sitting there going, he's doing something else that we're just not seeing, and the entire thing is going to crash. I'm checking logs. I'm looking at Apache. I know that there was something going on, and I wanted to make sure I did my due diligence to make sure that all of the pieces were taken care of, and that the rest of the people didn't notice anything. And in fact, RJ Casera, did I say that name correctly?
Yes.
He was playing while the hacking incident was going on, and he said he didn't notice anything. And so that's why. Go ahead.
It was right next to me on the train, and I'm watching the scoreboard, and I'm getting the stuff from Ben, like, you know, because you think about the organization, again, the mission of a CTF, fair and entertaining and enjoyable and fair. And I'm like, how's it going? Oh, good. I think I got a flag. I'm checking out. Like, as Ben mentioned, yeah, they didn't even notice.
So, and that's
Sorry.
that, and that falls down into the, you know, the compensating controls. Is that, you know, again, even though there was this, they were able to get that form submission without it checking against the database. The fact of the matter is there were so many other things that could have happened that weren't, because they thought of, you know, Josh thought ahead of time when he was designing the application. Can you hit that next slide for me, please? So my incident response was, you know, I went in, I stopped him, I got him, I removed his accounts, I got rid of his session tokens, his ASP ID, I found the code, I fixed it, and then I sat there literally for 3 hours. I ate my dinner on the couch with my laptop in my lap, watching and just waiting to see if the chuckle nut was going to do something else, and that's when I reviewed the other logs. So what did I learn, and what did we learn? One, there's always going to be a chuckle nut. If you release something, you have to release it with the mentality of somebody is going to bang on this just to see if they can. In fact, when we set up the wireless at B-Sides Detroit, the competition haven't even started yet, and somebody started banging on my box from their phone. And I'm like, really? We haven't even started yet. Leave me alone. There's always going to be chuckle nuts. You have to, whenever you put something out there, even if you think it's just on your own network, you have to imagine that one of your people is going to be that chuckle nut that's going to just see how far they can go with your application. I was one of those people. Whenever I was hired, I always wanted to see, well, can I do this with this application just for grins and giggles? The sanity testing, the sanity testing is an absolute must. Even if you think, I called this function from this function, there's really no other way to get here. Well, are you 100% sure? Well, no, not really. Well, sanity check the data. Are you supposed to get a string, or are you supposed to get this? Just do the sanity check. It doesn't impact the CPU. Monitoring the logs was absolutely essential, and without those logs that were in there, I would have never have known, except for the fact that you know, the scoreboard would have been blown up. And what he was trying to do, I actually talked to this person who I'm not going to name, but I talked with him afterwards, and what he was trying to do was do an integer overflow on us.
Trying to get the score high enough to do an integer overflow?
Yep, exactly, and it's just to bring everything crashing down to its knees.
Nice guy.
So that was that hacking incident, and you know, it made for an interesting and fun sleep-deprived event, and I got to teach my little boy about bad guys.
I think, you know, Ben 10 called it compensating controls, and I agree completely. Again, even the best of us make mistakes. Even the best applications have flaws. There will always be chuckle nuts. There's always going to be someone who's going after you, and it's really starting with that threat modeling and then layering in the defenses that directly apply to the threats that lead up again to the organization's mission that's key is incident response, logs. That compensates for a lot. And in this particular case, resulted in an incident that had zero practical impact. Do we want to jump back up?
But, you know, going back to that,
okay.
Yeah, but before we go on, you know, realize that the incident response plan is based off of what the capabilities of the application itself. And if you don't know what the capabilities are of your application and the security that's part of it, how will you know what proper incident response plan to put into place? If you have a, you know, you have an application, but you're not sure what its security capabilities or vulnerabilities are, so if you haven't done that and you haven't done the code review, how will you know what proper incident response plan you need in place? I knew what Josh's application could and could not do, and I knew that I had to have a manual process in there to review this because there was no automated alerting system. That it was just what didn't make it in before we had it released, and so therefore my incident response was sitting on the couch and watching the logs.
Absolutely. Any other thoughts on this particular incident then before we jump up in the slides and then come back to the other thing that happened?
Nope, that's fine.
Did you want to?
I want to return to
You
those.
want to return to those? Okay.
Yeah.
We'll go back to that.
So response and practice.
Okay.
We talked about talk about Ben slides here. Good. Stress the importance of quick response and limiting the business impact. I think we did. Okay, good.
See, these are well thought out slides.
Hey, yeah. This is like slide improv. Where's folks from? One of the new OWASP top 10. Did you want to talk briefly about the new OWASP?
Yeah, we'll do the announcement at the end. We'll mess things up here.
There is a new OWASP top 10. There's an announcement to be coming. One of the new ones is security misconfigurations. And it's important to note, of course, that no security is or no software package is an island. We're all dependent on the multiple layers of systems around us. And in looking at the breach that did occur, as he was doing his recon, he did find some misconfigurations in the actual system. For example, he was able to get some of the source code out of Git. And was there an SSL issue too, or was that something else?
I'm not sure.
Okay. So the bottom line, of course, is we're talking primarily today about SDLC, which is part and parcel of OWASP Detroit, which is part and parcel of software development, but it's also vital that you bring in the network operations folks to the system hardening. So when I did a formal SDLC process with FilePoint on our website, for example, we not only did attacks on the web apps, but we also brought in pen testers to beat up on our servers. So the same type of concept to look at it both ways when you're defending. And then,
Excellent.
yeah. Oh, yeah. See, there it is.
There it is.
Permissions review. Yeah, there's some additional permissions that were open that we probably should have hardened. Get on our server. They already get the code. Okay, good. So what do we got next? Some of the lessons we learned, as has already been driven home, even the most security conscientious makes mistakes. Reducing the impact reduces the meaning of any given breach. One thing that we did find interesting, when Juan was doing his scans, we triggered AWS and they blocked poor Juan. So it's important to note, again, that when you're doing scans remotely that you're notifying everyone in the chain so that they put an exclusion, they don't block you. We get the same thing here, right? If you guys are scanning us from your place, our ISP would block them. So you need to notify everyone in advance. And then we got another slide. No. So go all the way back down. After this incident, after Chicago happened, we had Mark take a look at it. We addressed the issues. As Ben mentioned, he put a patch in place, circled back, hardened it down, and then went and did the CTF again in Detroit. And we had one more issue that occurred, and then I'm going to turn it over to you to explain this one.
All right. So once we had switched over to Detroit, I was no longer point on the CTF organizing team. Derek was point on that. And I actually took some time off because I had been working nonstop ever since I got Josh's code on the CTF, and I just needed a little bit of time where I wasn't, logged into it. And so I wasn't paying attention, had no idea what was going on. And for those that didn't know, we also had a Twitter account that we had set up so that we could communicate with the participants and let them know when a new challenge is available and when the challenge is being pulled, for also hints and questions or whatever the case may be. Well, one of the codes was a hash cracking, or one of the challenges was hash cracking. And it was a lot simpler than what some people had done. So we had one participant, try to do it, but he couldn't get it done. So he came up with a way of getting a flag. Derek had asked me to put the new challenge up, and I emailed him saying, should I pull the hash challenge? And he's like, yeah, go ahead and pull it. So I pulled it. Well, this participant thought that this was a perfect opportunity to try social engineering me. And so what he did was he sent me a message saying, hey, I thought that the challenge was supposed to be up for a full 48 hours. Well, we actually never established that. Well, me, again, I'm just coming into this. I'm like, well, I don't know what time it was released. Let me check with Derek, and I'll let you know. And so I checked with Derek, and I'm like, hey, what time did you post this out there? Should we have left it up for the 48 hours? He's like, yeah, we should have. So go ahead and put it back up, but make sure it's pulled down by 10. I'm like, fine, I'll do that. So I put it back up. I'm like, yep, you're right. Go ahead, try it out. And in fact, RJ Casero was also very appreciative that we put it back up as well because he had the answer but just didn't get it posted in time. In the meantime, unbeknownst to me, this participant had already gone to one other participant and said, oh man, I would have gotten it had they not pulled it down. It was on a cracking box and I was so close. So how did you guys solve it? Well, they told him how to solve it, and they gave him the flag. Well, then I put the thing back up, and he copies the flag, pastes it in, and gets the points immediately. So, there really wasn't any incident response. We didn't know about this until at the BSides Detroit event, and he talked to the participant that did this, talked to me and the other guy, and we laughed and learned, and then I realized, you know what, it's going to happen, and no matter how secure we think we are, there's always going to be some room for failure, And the one lesson that I learned was, if I make a decision, even if it's the wrong one, I'm going to stick to it and say, you know what, I'm sorry, the challenge stays down, we're not making a change on it. So.
What I found interesting about this one, Ben 10, was, again, going back to what I was saying earlier, when we're in the middle of a workshop, between what you do and what I do, we should have known better not to make the code changes in the slide. Ben 10, you've got this whole talk, right, where you're focusing on user education and emphasizing the importance of being on the lookout for these things. It's going to happen to us. And even if you've done the SDLC properly, people try and attack your system. Even if you've done the SDLC properly, if they can't attack your system, can't attack your code, they're going to try and attack your people.
Exactly. And
so, go ahead.
Oh, I was going to say, exactly. And the thing about it is that when you think about your security, I mean, and I say this in my talk, but it's all about the layers. It's about, many different things. And unfortunately, there weren't enough layers to stop this social engineering attack. But, you can't set up your security to try and make it to where nobody can get in. Somebody's bound to get in some way or another. You just need to make sure you have something in there to slow them down so that you can identify them and get them out. So.
All about the layers. I thought that was a pretty interesting example of the way different people go about attacking us different ways. These are all very real-world things that we deal with every single day in a synopsis of what we as a team went through in an open source project. Do you have any other content you want to cover?
Nope.
Ben, did you have any closing thoughts before we open up to Q&A?
No, I mean, I think the only thing that I'd like to say is that, you know, this is very typical when you're dealing with development. It's not going to be, as has been said, the textbook presentation where everyone's on the same page and everyone has this nice layout of what's going to happen, and everyone sticks to the plan, and your coders are the best coders that you can find in the world, and they learned it. It's just not going to happen. And you know, it's very easy to look at organizations and say, well, why didn't you take care of this? When in fact it happens so often, and a lot of people don't even know about it because they don't do that review. And so we have to change the paradigm shift where we're not just focusing on, you know, securing the user and the blinky boxes and everything else, but where we start to, and I think, Wolf, I think your talk is on this, where you actually change the developers so that they think the same way that Josh is thinking, maybe a little bit better. Where they start to think ahead of time and say, hey, this is what we need from the get-go, and we can't compromise on it, so this is the way we're going to make it. So that's it. That's all I wanted to say.
And I would add, so what do we have here? We had Derek Thomas logging in inadvertently with clear text passwords, exposing all the challenge things. We started with that. We had the fact that, you know, we tried to make live code changes during an event and broke a bunch of things. We had a social engineering attack. We had a live fire attack where people, you know, were submitting a whole bunch of flags, trying to get integer overflow. We had a very rapid handoff of, yeah, I can do a half-hour, 40-minute call. Here, go, take the code. We're good. We had a 10-week schedule that looked great on paper that ended up being 2 weeks with 40 hours, with Ben 10 putting in a 20-hour day to try and get everything up and operational.
We had feature requests 2 weeks before go-live date.
I don't know who did that.
Yeah, that was Juan and you.
Okay, so we had managed. We had a lot of things happen in this scenario, and a lot of things went wrong. And yet, the mission of a CTF to do a high-quality job and to create a fair and enjoyable challenge was met. The participants, by and large, gave us great feedback. You know, people enjoyed themselves. It was a great time. It was a great event. A lot of energy coming out of B-Side Chicago, a lot of energy at the end of B-Side Detroit.
I mean, the great compliment, I think, is the fact that everybody was more concerned with, you know, fighting the challenges than with fighting the frame rate.
Scoreboard.
Right.
Absolutely.
Right.
And what that, I would say, is a huge, you know, very high level takeaway is we're going to fail, but that's okay as long as we keep in the right direction and keep adding compensating controls and keep at each other's backs. And don't point fingers and keep working together. And if we do that and we keep going in the right direction, we will be successful by keeping our eyes on what really matters. With that, any questions? No questions.
Well, you asked a lot during the thing, too.
So are you adding a feature for setting a time limit on the event now?
Time limit on the event.
Well, if you had a, you can throw something at them.
Okay. That would be, so automating the closing of challenges, that would be, okay. Don't give me feature requests.
Yeah. This is how it starts. Josh goes, yeah, that could be, I
could see how that could go, and with this, and yeah. So,
We could do that in 2 hours.
It's 3 story points.
I know, code it with one hand on a 2-foot.
Yeah.
Yeah, I mean,
and every feature should go back to the SDLC process too, right? You got to reassess your security.
And that's a good point, right? Because you again, that changes. That has a possibility of changing assumptions or challenging assumptions. that were made at the original get-go of the design. They may introduce new attack vectors to existing pieces that you thought were already secured until you throw this new avenue into it.
Right.
So yeah, so you definitely have to make sure that no piece of an application exists as an island or as in isolation. You really need to have a more holistic idea when you're adding features to applications, rather than I'm just adding this little piece here without consideration how that affects.
Come on, removing white space. What's that?
whole cloth breaking of anybody from being able to add answers whatsoever. So. Okay.
Anyone have anything for Ben 10 while he's on the line in terms of incident response or this side of it?
I want to thank you.
Oh, definitely.
Yeah. And an additional.
You can thank my unhealthy level of paranoia for that one.
There you go. Right, and we definitely have to give you thanks too for jumping in at the last minute and being able to complete that stuff. I think without that, this wouldn't have come off at all. So definitely big props to you for jumping in and taking up my slack at the end.
Hey, no problem. And with that, you're talking about the chain requests going through the SDLC. I mean, the fact of the matter is we actually didn't do a proper SDLC when I put that 20-hour day in, because I really didn't have anyone do the code review, but I followed your secure coding practices that was there from the beginning, and it allowed us to at least squeak past that a little bit due to the time constraints. So, I just can't reinforce the fact that when you're kind of putting these things is to think ahead of time and to develop it. And I know that we all don't have that luxury, but if you do, to really think from the beginning, think security at the beginning of it, and it just makes every little thing later on that much easier. So it was my pleasure.
You don't need any security on internal apps that eventually become external apps, right?
Right, because they're behind the firewall.
Yeah.
Nobody ever goes behind the firewall.
This one was what, all on your laptop for the first workshop?
No, for the first workshop, it was all up on our hosting provider.
Oh, it was on the hosting
Yeah,
provider?
okay. You're thinking of PicShack, which was on my laptop.
Oh,
PicShack is the exact opposite of SDLC. It is ISDLC, Insecure Development Lifecycle. So,
Yeah, as long as you have it on an internal network, you're fine. You don't have to worry about security. Your users will never attack you, ever.
Absolutely not. Absolutely not.
I agree.
I wanted to borrow before.
Okay, I think with that, I think we're going to wrap up. So thanks again, Ben, and we will.
It was my pleasure.
We will talk to you later.
Yeah. Thank you, Ben.
All righty.